This lesson will be about the Arrhenius definition of an acid and a base. I like to think of an acid as something that starts with H. And I like to think of a base, something that ends in OH. It's pretty simple. Now, the official definitions here, the last definitions are more like Wikipedia definitions. That is that the acid produces the H plus ion and the bases produce the OH ion. Now that works for a lot of cases, and that works for just about most of them. It'll work for all the ones today, and we'll learn later that isn't exactly true. There's a little bit more. But if we just take a simple acid, this is an Arrhenius acid right here. That's HCl, hydrochloric acid. And if we take HBr, hydrobromic acid, and if we take HNO3, that's nitric acid. Now remember, that's an oxy acid right there. That's a nitrate. So it has HNO3. So that's the nitrate ion. That makes it nitric acid. And this is sulfuric acid. If we have, that's the sulfate, and then that's sulfuric acid. Well, and then some natural bases right here are going to be sodium hydroxide, potassium hydroxide, and magnesium hydroxide. So if it simply starts with H right here, the presence of the hydrogen in that lone hydrogen will make it an acid, and the presence of the hydroxide will make it a base. Well, it can't be that easy, Russell, right? No, it's not. Okay. So we have to, let's just drop down to one acid right here. Now, let's say that we dissolve this in some water, right? Well, as soon as an acid is dissolved in water, it is going to ionize, right? So it's going to turn into a hydrogen ion, and it's going to turn into that chlorine ion, and then that goes away, right? And now these guys are just swimming around, okay? They can swim around wherever they want, okay? Well, that happens to all the acids. So hydrobromic acid just falls in there. So now we have the bromine ion, the bromine ion, and we have the hydrogen ion. And I'll save some steps. And you can see we've got the nitrate ion and the hydrogen ion right here. So for each three of these negative ions, we have three of the positive hydrogens all floating around. Now these are just positive hydrogens. They have no electrons. They're just protons. So they're just floating around there. That is exactly what makes an acid. It's just a proton. Very cool, right? Now you may have asked yourself, what about this guy? What if I ionize that? Well, if that's a legitimate thing. Well, what's going to happen? Well, am I going to lose both protons at the same time? Am I going to lose both of those hydrogens? Well, sort of, yeah. You're going to lose that one, and you're going to get that with hydrogen ion floating out. So you lose one at a time. And so we have that SO4 minus, and we have that minus charge right there. And we've got that positive charge. Notice that the positive and negative, if you add them together, you get 0, right? Well, that's the charge of that original ion. So the charges are still the same, okay? And then let's say that could dissolve some more, and then we get that extra proton out, and we could have that. Kind of cool, right? This is called a diprotic acid, which means it has 2 protons. That's kind of cool, and that is something that we'll use in your later chemistry classes. So if I was to write out if I was to write out HCl as aqueous, I could spread it out into H plus and Cl minus. Both of those are aqueous. Or I could have HCl aqueous added to water. And you remember that water is a liquid. And we can make H3O plus and Cl minus. So that H3O is actually probably the best way to say that. But H3O is telling you that this is also an acid. Okay. So it could be either this guy or this guy that's shown there, and either one of those is okay. Even on the AP test or IB test, nobody cares. Just to show you, the bases do the same thing. When they're ionized in water, we'll get sodium, and then we'll get hydroxide. We'll get potassium and a hydroxide, and then we'll also get magnesium. Now, there are two hydroxides there. You see that too? So we'll get two hydroxides. Okay? That will fully separate. And if you're going to write them out, I wrote them upside down because it's upside down day. And we have sodium hydroxide makes the sodium plus and the hydroxide. Potassium hydroxide makes K plus and OH minus. And magnesium hydroxide makes Mg2 plus and OH minus again. Mr. Russell, you did not balance your equation. So when we add these acids and bases together, we get what's called the neutralization reaction. And that's where we're going to make water. Okay. So it's going to be really cool where if we get NaCl, if we get HCl, and if we get NOH, now you remember that they split up into their ions. So let me grab their ions real fast and get those guys out of there. So now they split up, and now that Na and Cl are swimming around, all around, like crazy, because they're aqueous, and the OH and the OH are also swimming around. But as soon as they hit together, they make water. Okay, and so we end up making water out of an acid and a base. Now we also have this salt right here. So the salt is still present, but he is still dissolved in water, right? So they're still going to be swimming around. So you won't really usually see any change. This salt will be all that's left over. So that's why we say that we have salt, NaCl, and water left over. Now a salt could be anything. It could be KCl is still a salt. MgCl2 is a salt. And it doesn't really matter. It's the presence of that positive, either a group 1 or group 2 metal, and then probably a halogen, or and it's just an ionic bond. That's what we define as a salt. So if we're to write out these neutralization reactions, HCl and NaOH, I already told you, you take those two inside terms right there. It's a double replacement reaction, right? Like you've already done. So the inside terms go together and the outside terms go together. So H and OH. It's not HOH. No, 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 no. We'll take off a point for that. You want to do H2O, okay? And H2O is a liquid, right? NaCl is aqueous. These are all aqueous right here. So all aqueous will just move on. And so HNO3 and NaOH will make MgOH2 and HBr. Okay, so I got some weird stuff going on here because that doesn't exist. And so I have to fix my products right here. Remember what I told you, take the inside terms and just go ahead and write them down, and then fix your products. So Mg is a 2 plus charge, bromine's a -1. So that means I should put a 2 right there. So to make 2 -1 charges to cancel it out. And since there's 2 bromines, I should have 2 bromines over here. So I have 2 hydrogens, 2 hydroxides makes 2 waters. Okay. And then H2SO4. Okay, fix your products again. KSO4 doesn't exist. Make it K2SO4. And then put a 2 right here to balance that potassium. 2 hydrogens, 2 hydroxides makes 2 waters. So each one of these is my salt that is still aqueous. I didn't just precipitate out a whole salt. And each one of these is my water. That's going to be it. That is acid-base neutralization and the Arrhenius definition. Have a good day.